Guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at the concept of derivatives of functions and the mean value theorem. And this is going to be having assist us create a connection between these two specific concepts. In a sense, we're going to see that the mean value theorem is basically going to be describing a special case of particular derivatives in comparison with a range or rather a point between a particular kind of interval. And in our previous discussion, basically we have dealt with the concept of the mean value theorem in details. Now in this specific discussion, basically we're going to look at how we can describe a range of these specific points, of course in relation to these derivatives. And that is going to assist us describe various types of curves in terms of either increasing and decreasing functions. Now, in a sense, I'm going to particularly give a summary of this specific aspect of the mean value theorem. And as we said, this mean value theorem, of course, is going to be very fundamental for us in trying to describe some of the specific points. Now, the mean value theorem we had said basically states that if we have a function, if a function given as f is continuous on closed intervals, of or we can just give them in closed intervals of a and b, and differentiable on open intervals of a and b, and there is a point C such that C is a point between A and B, whereby C is greater than A but smaller than B, and or we can have this one then the first derivative with respect to C of this specific of course function can be described in terms of the derivative of fb minus fa all over b minus a, and this is going to be giving us a summary of basically the description of this specific concept of the mean value theorem, which states that if a function f which is continuous on closed intervals a and b and are differentiable between the open intervals of a and b, then there's a c, we can have this one, there's a c or a point C such that this point C is located between the intervals of A and B. And then we are going to have this particular description for the first derivative with respect to this specific point C, given in terms of the derivative of this range of values between A and B given as such. And in a sense, we're going to see that this mean value theorem is going to be assisting us to describe a graph of a particular nature, whereby we're going to see that if we have a function that can be described on x and y coordinates system given as such, and if we have a function which is going to be given in terms of the points of A and B, we're going to see that for the various coordinates of this specific point given for A and FA, B and FB for the coordinates of B, we can find the derivative of this specific function between A and B by giving it this specific description, whereby we're going to have f prime of this specific point between A and C given in terms of A and B given in terms of FB. So this is going to be the change in of course y all over the change in x given as such, and this is going to be a derivative given as such. So if we have a point between these specific intervals of A and another of course set of these intervals for A and B, so there's a particular point C whereby we're going to see that this specific point, the derivative of this specific of course a range of course a value from A to B, which is AB, is equivalent to the derivative of this specific function at C. and these are going to be the coordinates of C and FC, which are going to be given as such. So in a sense, it's going to imply that basically these two lines are going to be parallel. And we have decided that we are going to have a special case of the mean value theorem, which is going to be referred to as Rolle's theorem. Now, in a sense, Rolle's theorem is an advanced form or a special case of this mean value theorem, whereby we're going to see that there's going to be an additional condition on this top, of course, so this is going to be a theorem. On top of this specific aspect of the mean value theorem, we're going to see that there's an additional condition whereby on top of this specific function being continuous on closed intervals a and b and differentiable on open intervals a and b, there's going to be a point c such that the first derivative of this specific point, which with respect to c given as such, is going to be giving us a value of 0. So therefore, that implies basically that there's going to be a point in this specific function which is going to be having a derivative of 0. And in our last discussion, we said that basically this point can be defined as a point that is going to, or rather a point or a function that's going to be defined of this specific derivative of a line that is parallel to the x-axis. And we're going to see this specific description for the point given as such. Now, in our subsequent video, we're going to, or rather in our subsequent discussion for this specific video, we're going to see that there's going to be a range of description for such functions, and we're going to give them in terms of equation forms so that we can be able to, of course, appreciate them. And that is going to assist us create a connection between this specific theorem that we have mentioned and different derivatives of functions, which are going to be assisting us try to describe them, and of course try to formulate or sketch a range of curves from this specific description. So in a sense, if we have said that we're going to have this particular function given in terms of f, so this is going to have an implication that if this particular function f is continuous and differentiable, then we can describe this specific function or the derivatives of this specific function in a range of ways, of course, with respect to the mean value theorem and the Rolle's theorem, which I've just mentioned. So we are going to have this specific function continuous and differentiable on closed intervals a and b, and of course differentiable on open intervals of a and b respectively. So if we have a case whereby we are going to have these specific functions, so let's have this one as one, whereby this specific function for x, the first derivative with respect to this x can be given in terms of 0. This is going to imply that for all values of the value of x, where x is a set of a range of values in these intervals given as such, this is going to imply that this particular function basically is going to be a constant. So this is going to be giving us a constant in a sense that we are going to have this specific function. So in our previous video, I said that for us to have a derivative of a function which is going to be constant, then if we have a point which we can describe in terms of x, then we're going to have another point of this specific description which we had said, which is going to be a point c, whereby c given as such, whereby the derivative of this, so basically it's going to be given in terms of x and fx. So whereby we are going to see that the derivative of this specific function, which is f prime x, is going to be 0. So that implies the change in y-axis for a description of the derivative, which we had given in this specific format, is going to imply that the change in y is going to be given as 0. So therefore implying that this line basically for a constant is going to be a line parallel to the x-axis if we consider the two Cartesian coordinate system given as such. So we'll be giving a range of other conditions which are going to be describing these specific derivatives, and this is going to be forming our first set that the first derivative is equivalent to 0, then therefore that implies that this is going to be a constant function for the derivative given as such. So if we have the first derivative, of course, given as such, which is going to be greater than 0, so for the values of this specific, of course, value of x that is going to be between these specific intervals, then this implies that basically this particular, of course, function can be described as strictly increasing. Now, in this particular case, we had talked about the concept of increasing and decreasing function. And with respect to the second, of course, condition for this one, we're going to see that if we have a function of f prime over x, which is going to be smaller than 0 for the range of all range of values of x, where x is a set of this specific interval, then we're going to describe this specific function as strictly decreasing on these specific intervals of a and b. And if we have a range of values for this specific function, which we are going to give as f prime over x is greater than or equivalent to 0. So this is going to be implying that so there's going to be a change of wording for these particular intervals, whereby we're going to have this one implying that this is going to be an increasing function on these particular intervals, whereby these are going to denote the particular intervals that we're going to consider in this particular case. So we're going also to see that if the derivative of this specific function of f prime x is going to be smaller than or equivalent to 0. So for the values of x, of course, between a and b, we're going to see that this is going to be described as a decreasing function on I, whereby these are going to be described for these specific intervals. So this is going to constitute a range of conditions which we are going to consider for the various range of curves which we have described basically for the various range of derivatives, where I've said that we're going to consider this as a change in y over a change in x of a specific set of points for a function. Now, in this particular case, we're going to combine this particular discussion with a range of other videos, and these are going to be assisting us try to perform a specific procedure that we refer to as curve sketching. So this is one of the procedures that we're going to, or the procedure that we're going to consider. So kindly remember these specific conditions, or understand these specific conditions for the various range of derivatives which are going to be considered in this particular case, and particularly the wording which we are going to be using in describing this specific condition. So kindly check our description boxes for various links of other videos. Engage us in the comment section, and also ring that notification bell for a number of updates on a different discussion. So I'm going to put a link there in terms of a playlist. Open it and check. It's going to be consisting of videos with the same, of course, topic and a discussion. So that is it for now, guys. By God bless. We catch us in our next video.